So when I accepted the call for this keynote, I wasn't sure what I was going to talk about. I decided to start by taking a look at last year's material, and I came across David's great talk, One Step Beyond. Hope you caught it. And in it, he talked about some of the great capabilities that MarkLogic was developing, including, and now in the product, elasticity, the ability to manage the resources so that the cluster infrastructure is best utilized and save money. He talked about context, the representation of facts, both in documents, augmenting documents, and out in the real world that could be added into the database to provide more contextual information. And then he talked about semantics, and that really got my attention. Semantics, standardized means of representing facts and information. Semantics. Because Intel had been looking at semantics as well, but from a different perspective. So at this point, you should be asking yourself, sometimes I even wake up and ask myself, what is Intel doing in this space? This is a hardware company. We're also a software company, and we believe in the virtuous cycle of the data-centered data center and the data within it. We believe that intelligent systems are being deployed in retail, in manufacturing, and vehicles, and elsewhere that are generating tons of data, and it's very rich with metadata information. That information is being sent up into data centers where it's being processed, demanding more analytics capabilities and more storage. And that's leading to richer user experiences. And in turn, those experiences are causing demand for these intelligent systems and the machines in the data center that back them. And that's why Intel is interested in this virtuous cycle of data. And I believe that semantic information is a very important fuel for that cycle. But, you know, it hasn't really been a fuel for all that long, has it? Only recently did we come up with standardized ways of representing triples and other types of semantic information with the semantic web. And then pioneers like MarkLogic figured out how to build enterprise database systems around that. And now we're in an era of unification, where we're finding ways of combining that semantic information with other very useful information. I'm really happy about that because I personally don't believe in these silos, and I've seen too many of them in my career. And now I think we're on the very cusp of applying very advanced analytics that are easy to think maybe impractical, but are actually being applied today. They were applied 10 years ago by the big data wizards, and now I'm seeing them pervasively within even stalwart companies. Machine learning, just a fancy way of talking about optimization using algorithms, solving optimization problems. So I want to talk about what data scientists that do machine learning, how they view this type of semantic information. Now here's just a representation of triples, facts about the world. Danny is brother of Nezzy. Frank likes bicycles. Ivy likes bicycles, and so on. Data scientists that work on machine learning like to build data models. A lot of the rest of you as well that don't do this as well. Data models are really important and crucial to solve these kinds of problems. Here's a representation that's a little bit clearer about the relationships that are represented by that semantic information. And here I am with my trusted network, and I have my interests, and this data model can represent this heterogeneous information. People, places, things, the facts that are relevant. And my trusted network also has interests like in food carts. And there are maybe even food carts out in the world that use bicycles in their business model, which is quite a strange thing. And we can make interesting inferences that are not that obvious. And there are some people that are very interested in that. Now, I'm from Portland, Oregon. It's a quirky place, and I'm an adventurous person. But I can tell you, when my wife asked me to get on this bicycle and make a smoothie, I was a little bit dubious. But I can tell you, there's a business owner out there that's very excited about the fact that there might be a recommendation system that you can build on a model like this to help the power of their business. So imagine the possibilities. I want to broaden the scope for a second. These things are really practical, and let's look beyond the toy problem. Imagine the enjoyment from being able to study channel surfing behavior. We did this with a broadband provider, the biggest broadband provider in Canada. The nodes representing channels, the edges representing changes between channels. Imagine if we can, in time, analyze this behavior and recommend better content more intelligently, and then target advertising based on the most tread paths through this graph. Imagine doing that at scale. Imagine the security of a world that can use these data models that would create of tens of billions in this graph with our McAfee subsidiary, tens of billions of nodes and edges that represent files and IPs and domains and the threats they represent. And imagine if we could label all that unknown gray area information with reputations. Imagine how safe the world could be. Imagine the satisfaction of connecting people to exactly the content they prefer at a personal level. Building recommendation systems based on graphs. What cast do I prefer? What topics am I interested in? Finding the least cost path through these graphs fast. At graph scale, with millions of edges and nodes and more. But you know what? There's a lot of hype around graphs. In fact, I think it's only dwarfed by the hype around big data. And I hate to say it, but it's even showing out in my workup programs. So, a yoga ball graph, really? I don't understand the relationship. But you might actually need a model like this. They are very practical. This is not Star Trek. You may consider it when the problem is naturally a graph, an information network like the internet, web links, or the connections of neurons in a brain that neuroscientists might study, or when it's a natural way of expressing an algorithm like a Bayesian inference problem, and a better way of expressing it than factoring a function. When you want to study specific relationships like that media system I showed you, or when you just want to simply do faster learning on the data and solve it on sparse data that's sparsely connected, like a lot of the real-world problems are. You might actually need a model like that. But even if you understand that and you know how to build one, there are challenges. How do we handle all that data? Well, MarkLogic's making great progress on that. But with that, how do we find good people that are good at both handling that data and doing this type of analysis? And how do we put exploratory work for some of these amazing solutions into production fast enough so that you can keep up with your competition? There's a crisis forming here. I'm sure you're aware of it. And if you're a data scientist, it's great news. It's going to be really hard to find people that have skills at these intersections of capability. And we may be having a shortage of a couple 100,000 in just a few years. And it's not surprising when you look at the kind of job we're asking them to do. MarkLogic's helping to get companies doing easier ingestion and cleaning of data, but then we have to, as data scientists, to engineer important features out of that data, build these complex models, train them using advanced algorithms, so that we can put data values that are associated as new metadata, and then present them to systems and people for analysis. And it's still painful to do the ingestion, and there are lots of loopbacks in this, which is what takes all the months to get that done. And of course, composing a pipeline end-to-end of the type with all of this capability is really do-it-yourself still, with few tools, and a few that we know about more today, for doing semantic analysis at scale. So it's not a surprise that we have this skill shortage. But we can imagine a data platform that combines the capabilities of documents, semantics, advanced machine learning, and I think you can imagine part of that right away. And we can build that on great hardware that's optimized for these types of algorithms and work, and leverage the NoSQL storage solutions that we just heard about. Then we add in-memory and analysis engines that work out of persistent storage that can take advantage of all that information database-wide. Many of these problems are requiring full-scale analysis, the ones I mentioned. We put in place better tools for building these types of models and better operators for handling that information, and add to it a really effective package of graphical and non-graphical algorithms, because again, we don't want to create silos. And on top of that, we present it in a way that data scientists will want to consume it. They're familiar with the queries. We talked about Sparkle, we talk about SQL all the time. And we can add other scripting languages, Python and R, that data scientists are used to using today, and bring the system to them. And I think that, and that is what the Intel Analytics Toolkit is that we have recently announced and that my teams have been working on. And it brings all this to bear on these NoSQL storage systems. And I think that with MarkLogic, we have a great partner that knows the importance of unification. We not only want to unify graphical and non-graphical, but all the storage needs and database query needs that we have for this type of system. And it is a heterogeneous problem. So this is really good news for Intel and for the ecosystem. And with that kind of system, you can do a huge spectrum of things. And the spectrum of things you can do will transcend graph and non-graph, as I mentioned. Now, you may not be familiar with a lot of the names of the algorithms on the left-hand column here, but I bet you're very familiar with the use cases, and you see very practical ways of using them in your businesses, and probably some familiarity with the categories and the methods that are used to unlock things like fraud detection, recommender systems, and pattern recognition in general. And so the Analytics Toolkit will do that for you, and we've drawn a careful line as to what we want to apply using graph methods and what we want to use other conventional methods to do. So with that, I want to help you reimagine 2014. And you've seen probably some recent announcements around new partnerships, strategic partnerships in big data. Intel wants to fuel the ecosystem at large and want to accelerate the work with great strategic partners and new ones yet to come this year. We want to continue our contributions and accelerate them to the open source community and get this analytics toolkit out. And I think that it'll be great when we see semantics put together with this advanced analytics and when the hype goes away and we get down to real business with it. So thanks a lot for your attention today. Enjoy the show.